Welcome again, exciting, ever fascinating world of chemistry. We're looking again at kinetics, and we're looking today at rate law. Rate law is defined as the means of determining the rate of a chemical reaction. Now, it's different from instantaneous or average rate of reactions. We're looking at an equation to work at from our chemical reactions. Now, unlike equilibrium, where we use the coefficients as the values, we're going to get exponents again for the rate, but those values do not come from my coefficients of my chemical reactions. So instead, we have to find them. So write all this fun stuff down. We're going to work with this in order to give me the way to come up with the rate law. So we're looking at these three different reactions. We have a concentration of 0.0100 molar, 0.200 molar, and a rate of reaction of 5.4 times 10 minus 7 molar per second. You have the other two. Now, we choose these specifically because between the first and the second rate of reaction, the concentrations are the same. When we put them in the equation that way, they'll cross out. We do the same thing for the second and the third reaction because when we compare those will cross out as well. So looking at our rate of reaction, we find out what the X and Y value are. So looking here, we're going to start by comparing reaction 1 to reaction 2. So we're going to take reaction 2, so the number is larger, over reaction 1. We put our values in. We have 0.0200 molar for the concentration of ammonium. We have 0.200 molar for the concentration of nitrite. And then in the reaction 1, it's 0.0100 molar and 0.200 molar. We do, and that's going to equal 1.08 times 10 minus 6 molar per second over 5.4 times 10 minus 7 molar. We do that so our K's cross out and our concentrations of nitrite cross out. We're going to get a relationship here of 2 to the X, because that X we still don't know, is going to equal to 2. So what value of X will give us 2? 1. So that tells us that the exponent there for nitrite is going to be to the first power. All right, let's do the second value between reaction 2 and 3. So there, we're going to take the setup, 3 to 2, put our values in. Again, the K's will cross out. The concentrations of ammonia this time will cross out. And we're getting a relationship of 4.32 times 10 minus 6 molar per second over 1.08 times 10 minus 6 molar per second. That's going to be 2. The Y is equal to 4. What value gives me 4 if I take 2 some exponents? Of course, that's 2. That means that my exponent for nitrite is going to be 2. Now, that's my rate law. All right, so when we go through this here, that was another example. We'll do that in class to make sure and we'll go a lot slower so that way it's explained better. All right, now the other thing you need to understand is the order of a reaction. Order of reaction means they're expressing the rate law. It's very simple. It looks complicated. Copy these down. But all we got to do for determine the rate of the order of the reaction is count the exponents. We have a 1 understood to be there and a half for oxygen. So you put those together, we get a 1.5 order. We'll do the second one and third one in class to make sure it's understood. All right, so last thing we can do is determine the rate law constant and calculating the rate. So we go back to the problem we did in class together. So here's our value. That's the rate law we had. We take the first set of conditions because it was the easiest to deal with. And basically all we're going to do is put it back in to solve for K. So we're going to take 5.4 times 10 minus 7, divide by 0.0100 molar to the first and 0.200 molar squared. We end up with a K value of 0.0014 molar per second. That's our first value in half. Now the other thing is we have a set of conditions. What is the rate when the concentration of ammonium is 0.100 molar and the concentration of nitrite is 0.1000 molar? So we just take our equation, put our K value in, put our concentration of ammonium and the concentration of nitrite in, and we get 0.000014 per molar per second. That would be my rate of reaction. So those two are my answer to the problem. All right. Let's go do this one in class. Make sure it's understood. Any questions, let me know. Take care. Be good. We're done. And